Every AI breakthrough looks like software, but before the model, before the data center, before the chip, there is a rock. In the mountains of North Carolina, a rare form of quartz helps make the silicon world possible. This is where the cleanest materials in chip making begin. Purity here is not a detail, it is the point. From quartz to crucibles, to crystals, to wafers, and finally, to AI chips. Spruce Pine looks like a small mountain town. Quiet, modest, and easy to miss. But beneath this landscape sits one of the most important mineral deposits in modern technology. For decades, this district has supplied ultra-high purity quartz to the world. It looks like any industrial site, until you learn what lives here. Specific ore bodies, specific geology, and it connects to places that build the future, from a rural ridge to the cleanest rooms on Earth. This is where the chain begins. And the reason is purity. Quartz is common. This quartz is not. Value lies in purity, low contaminants and consistent chemistry. It can be refined into materials used in the cleanest industrial processes on Earth. Think parts per billion impurity control. Iron, aluminum, titanium. Each trace must be driven down. Processing takes a clean feed and pushes it to extraordinary purity. Mechanical sorting, chemical leaching, and thermal steps, all tuned for contamination control. Not all sand is created equal. Traceability matters when a flaw can ruin a crystal pull. Sampling and specs make the difference between commodity and critical. Because in semiconductors, purity is performance. To make advanced chips, manufacturers first need silicon wafers. Those wafers begin as crystals grown at extreme temperatures. The vessel that holds molten silicon must be extraordinarily clean. Any contamination can seed defects. From melt to a single crystal, meters long, flawless by design. Then it is sliced, polished, and readied for fabrication. Layer by atomic layer, circuits emerge. None of this starts without high-purity quartz components upstream. The cleanest rooms on Earth depend on the cleanest inputs. Here is the chain. At the far end, AI accelerators driving a new wave of computing. At the start, a rock, chosen for purity. The Spruce Pine story is also a story of concentration. Two companies dominate the rights and operations you need to know. Sibelco, from Belgium, and the Quartz Corp, from Norway. Together, they sit at one of the earliest and least visible stages of the semiconductor supply chain. Their output feeds crucible makers and component suppliers around the world. A quiet upstream link with outsized leverage. Control over suitable ore bodies and processes is key. This is a global supply network beginning in North Carolina. Specifications, contracts, and quality gates keep it tight. Remember the names. Of those two names, Sibelco is the one with a stock market listing. Sibelco is traded on Euronext Brussels as SCR Sibelco NV Display, ISIN B09442646663. It is a reminder. Advanced technology can have exposure to a very old industry. Mining, niche materials, strategic impact. From ore bodies to AI wafers, the chain is real. Facts, not advice. Mining, materials, markets. Global stories start in local places. And in this story, two companies matter. A chip fab in Taiwan may seem far removed from a mountain road in North Carolina, but supply chains connect them. When weather, logistics, energy, or operations are disrupted upstream, risk can move downstream. From quartz supply to crucibles, from crucibles to wafers, from wafers to chips. Logistics link local weather to global schedules. Even small delays can compound. No need to exaggerate. Not all chips stop instantly. But concentration at the source means fragility is real. The world's most advanced fabs rely on fragile upstream materials. AI demand has made advanced chips strategic. Designers, fabs, lithography, yes, they are bottlenecks. But so are the raw materials almost nobody thinks about. A microscopic defect here can trace back to a geological choice there. The chain is only as strong as its first links. Understanding upstream risk is part of understanding AI. As AI scales, inputs matter more, from one town to many fabs, from geology to computation. Digital intelligence has a physical supply chain. The next AI breakthrough may be trained in the cloud, fabricated in Taiwan and designed in Silicon Valley. But one part of its story begins in North Carolina. In Spruce Pine quartz, refined to extraordinary purity, controlled by a small group of companies, and quietly embedded in the foundation of the chip age. AI may look digital, but its foundation begins with geology, mining, purity, and tightly controlled supply chains. The AI chip starts here.